Right, so I'm just going to give you a practical demonstration of laminar flow, and I'm going to substitute the air here for water. So if I turn this water on, and I hope you can still hear me, what actually happens is as the frame moves through that laminar flow, that's the effect that the air is actually going to receive. So you can see how much, as soon as it goes from a laminar flow, which is nice and you see it's like a nice direct pull, and as soon as we put that frame in front of it, no, it breaks it all up. That's what induces your drag. So as soon as you go from laminar to turbulence, you start to get drag. So that's on an 8mm arm. That's what you would ordinarily expect from a frame. And if I turn it on its side, and let's pretend that this is actually I believe that's 5mm. You can see, and I'm really struggling to hold the camera here, but you can see once again, as soon as that water starts to separate, that's where you're getting a drag. It's okay if it passes over and it's acting as a sort of, what's the word I'm looking for? It's spread out a little bit because it's still laminar to a degree. It's not as perfect, obviously, but it's not going to produce the same amount of drag. But you can see, it's even in the best case scenario for this frame, where I turn the arm upside and it's only 5mm thick, it's still producing a lot of turbulence to that laminar flow. So, this arm, let's have a look at that one. You're still going to get some disturbance or turbulence where the braces meet in the middle, but it's nowhere near as much. So, I can put, you can see that's not, that side there, it's not inducing any turbulence whatsoever. And if I move back over here, again, same thing, just so you can see, it's still maintaining its laminar flow. If I move over this part here, that's where you're going to get some disturbance to the flow. But if I bring it around, you can see it's not actually completely broken up. It's still maintaining a laminar flow. It's still connected to itself. So even though you've got a little bit of a disturbance there, it's not as bad as what you would expect. That is the worst case scenario for this frame. But as you move the arms over it, you can see it just does not break up nearly as much as the other one. And I'm pushing this to flow through the worst case scenario areas. And don't forget, this part here, this is where you're going to get your most drag from. So on the struts and everything else, that is completely solid. I've actually got this tap turned up as high as possible too. But that, yeah, so this part here is your worst case scenario, but it's still producing so much less turbulence than the other one. And the other thing is, a lot of a lot of manufacturers are going for really thin arms, and that's good because it disturbs the air less. But one thing that you're still missing is that a lot of these frames, particularly because they're hybrid strep chexers, still have a big flat top plate. So as soon as you get that in the center, it's not even worth really trying to demonstrate that because it's all over the place. So again, we go to a conventional arm, and put that down a little bit. You can see, look at how much that is disturbing the air. And that's actually going to be power lost coming from your motor because that just induces drag. And this is at a very low pressure too, don't forget. I've got the tap up as high as it'll go, but yeah, you can see how big a difference it makes when you've actually got a foiled surface. It's just, there's no comparison.